All right. We're back again, week number 3 with Mr. Vladimir Vivien, giving you 2 weeks of not just knowledge, but knowledge that you can use right now, ready to go knowledge. I'm going to turn it over to Mr. Vivien to bring us into the third week. I look forward to you interacting with you in the comments. We're going to drop as much knowledge as we can. Over to you. You still on mute, Vladimir.
And I had this awesome introduction.
It's all right. It's all right.
All right. Let's try again. Okay. So sorry, I was talking on mute for the last 5 minutes. Anyway, hello. My name is Vladimir Vivien, and this is our third episode. So for the last couple weeks, and maybe a few more weeks coming, we're gonna be talking about the Go programming language. So if you're programming in some other language like I don't know, Python or JavaScript, and you're thinking about starting your career in Go, or just to pick your interest, this is the series for you. And basically, what we're doing for about 10, 15, maybe 20 minutes, we're going to talk about Go, and hopefully, you'll learn something. So, about me, my name is Vladimir Vivien. Once again, I am a software engineer, and I'm also an author. And I've written a book about Go called "Learning Go Programming." You can find me on Twitter at Vladimir Vivien, as you see on the screen, or you can check me on Medium, where I blog about this stuff as well. So this is our agenda for today. We're going to do a quick review of what we talked about last episode. And then we're going to look today, what we're going to do is project organization. We're going to look at what is a Go package. Also, we're going to touch on what modules are, and we're going to do a quick demo of these concepts. Now, before we go on, I just want to make sure it's probably going to take us another episode before we jump deep into the Go language itself. And the reason why is because the fundamentals are very, very important. If you understand some of the concepts we'll be talking about today, and some of the concepts we talk about, we kind of alluded to in the last series, they're very important because they will cut down the amount of frustration that you may run into if you're trying to pick up Go. Because I've seen, I talked to a lot of people doing Go, and I remember myself when I was starting to Go, when I started with Go. One of the things that always threw me off is, how do you set up project? What does it mean to have a package? And now we have the notion of modules. What does all of that mean? So we're going to talk about all of that today. And next week, we're going to start looking at Go types and variables and functions, etc. But today, it's all about setting up projects and project organization. So let's do a quick review of what we talked about last time. Last time, we talked about how you get started setting up your environment. We talked about where do you go to download the Go tools. Then we talked about what IDE to use. We settled on using VS Code. So we showed you where to download VS Code and how to configure VS Code so that it supports Go and provides you with all the tools you need when you're writing Go. And we took a quick look at a very simple language or I'm sorry, at a very simple program to basically show you how to get started with the environment once you have it set up. Now, today, as I mentioned earlier, we're going to look at project organization. What does it mean? What do you need to do when you're setting up your Go project? What the different constructs, such as packages and modules, what does that mean? So, Go source files are organized as directories, and those directories are called packages. Um, so here's an example here. When you create a directory and you put your Go code in there, that top directory is your project root. Okay, it itself is also a package, and then inside that project root, you can have sub packages or subdirectories, and subdirectories can be embedded inside one another. And then inside these directories, you can that's where you put your Go file. So you create a file .go, whatever that may be. And we'll see an example when we get to our demo section. So what are packages? A package is a unit of code in Go. So we already seen that a package is a directory, and inside that directory, that's where you put your Go code. Now, there are two types of packages in Go. One type is what we call a library. I touched on that a little bit last time, but we're going to look at that today. So we have libraries, and we have packages where whatever's in that package become what can be executed or your program. So libraries, they're meant for code reuse. Okay, so if you have some sort of as the name implies, if you have a set of code that you want to make available either for your project or for external projects, then you create libraries. They can have arbitrary names. You export types that you have inside your libraries. There's a way to make them visible to folks who want to use your libraries. They can be imported by other libraries, as I mentioned. And your code can also import other libraries, whether those libraries are local to your project or external to somewhere else. As I mentioned, programs, they're special types of libraries, right? They're special type of package. They indicate the entry point where you want your code to start executing. One requirement is that you must name that package main, and that package also must contain a function called main. Basically, what we're doing is helping out the compiler, the Go compiler, so that it knows when it compiles a program where that program starts. So basically, those are the requirements. So let's take a quick look at what modules are. Because we talk about package now, there's another concept called modules. A module does two things. It declares a namespace, basically an identifier for packages in your project. And we'll see what that means and what that looks like. And it also creates a collection of package dependencies for your project. So if your project relies on external packages, in your module, you would declare where those packages are and how to get access to them. And again, we'll see how that works. So when you're starting a Go project, you create your directory, your root directory for your project or your root package. One of the first things you're going to do is type this command. So go init followed by the namespace or some sort of ID for your module. Now, I just noticed I made a mistake, but I'll show you exactly what this should be. But this is missing something. Anyway, it's go mod init, and then you pass it the name of the module. So when you do that, the Go tool will create a file called go.mod, and inside of it, it'll have the module name. Remember, a module basically declares where all of my dependencies are, but also it declares the name for this current module which I'm working on. So this is what we're seeing here. So the module name that I'm working on is go_in10/example, and the name can be arbitrary. And then the second line is basically the version number of Go that I'm using for my module. So what does it all mean? So now once you say go mod init and you give it a name, now the compiler and all of the Go tools that you use with Go, they know now how to treat your packages. So at the very top, as the root, everything, the module is known as go_in10/example. So all the tools in Go knows that what you mean when they see that namespace. And then now you can reference from within any Go code inside your project. You can reference to your internal packages by prefixing your package with that module name. As you can see here, we have go_in10example/pack A for this package, or go_in10example pack A/pack B/pack B for this package, because pack B is inside pack A, and so forth and so on. And then of course you have your mod file. So now that was a quick overview of what packages and modules are. Let's take a look at several examples, and then which will clarify these concepts. All right, so now let me find my screen here. Okay, so now I have, let's look at the first example in this directory here. Okay, so that's what we're looking at. So the example we're gonna look at today, and we're gonna keep developing that example, is basically a program that tells us time, and then eventually we'll see how to turn that into a server, et cetera, et cetera. But for now, what we have is a simple program that basically is inside this. So actually, we could show you what's going on here. Now, this particular directory is the root directory for this project, although this project only has one file. And inside that project, we have the now.go. Okay. Now, because I want that particular project to also be a program, meaning I want it to be able to run, I have to tell the Go compiler what I want. I want to tell it that this is my starting point. And as I mentioned earlier, one way to do this is to say that this file is the main package. It's part of the main package. Okay. And remember, main is a special name. You really shouldn't use it unless unless you're building a program and you want the Go compiler to know that that's where your program starts. And then what I also said was you also need a function called main, so that the Go program or the Go compiler knows that you are writing a program and this is the starting point. So if we come here, let's see, where am I? Okay. F3. 1. Okay, so if we come here and we just run this program, we'll just run it. And basically it'll do exactly what we ask it to do. Couple more things I want to point out before we move on to the second version of this. It's the fact that we are importing other packages. And the way we do that in Go is through the import block. So in the import block, we say that we want to import the time package and the FIMP package. I mentioned that last time. And these packages are from what we call the Go standard library. And because they're from the Go standard library, they have, the names not necessarily reserved, but you don't have to specify a long path for it. The compiler knows where they are. Um, and you also don't necessarily need to specify those in a module file, because if all you have is just simple, if all you have is dependencies on the standard library, you really don't need the mod file, because the Go compiler can resolve it. But it is a good idea to always start with a mod file. All right, so I wanted to point that out because that will come in handy in the next version. So we run this, and basically what we're doing is using the print function from this package, the FMT package or FEMT, and we're printing, we're using in that function, we're saying we want to print the current time, and we pass it so that package time has a high level function called now, which return a string, and that string contains a long version of the representation of the current time. So that's exactly what we're doing here. And if you look over here, you see the output of the program where it prints out a long version of the current time. Now, let's close this and open the second version of this, and where now what we have is, in this particular project, I have a subdirectory, which is a package. Now, let's look what's in here. So I want to, I'm going to change the program, but what I want to do is to print time and different time versions, or different, print the time in different ways. But the way I want to do it is that I'm going to put all these functionalities in a package, in its own package. And that package is called lib, or lib. And it has one Go file, timelib. Now, one thing to note, now I'm no longer calling this main, because it is not meant to be a program. It is meant to be a library. I'm just happen to call it lib. I could have called it anything else, right? It's very arbitrary. So you don't have to call it lib. You could call it whatever you want. So I just call it lib. I could have called it time lib. I could have called it something else. So that's the package. So this file, or this package declaration up here in this file, is telling Go that this file is part of the lib library, and it imports the time package. So it's importing a package from the standard library. Now, in this library, what I want is expose different functions that can render the current time differently for me. So I have one called long time, which basically does what we did earlier. And then I have one called short time. And short time is going to print the time in a shorter format. Now, that's good enough to get through our concept, so we don't have to make it any more complex, okay? Now, if we go back to the now.go program that which we had earlier, now you'll notice not only I'm importing FMT or FEMT, I'm also importing a new package. And this package is my package. That's the one I just declared. Now, a couple of things I want to point out. Let's go to now2. So now2, if we do a list, you'll see that I have, I want to make sure you can see that, I have a go.mod already. So meaning what I did is earlier I came in here and I typed go mod init, sorry, and you can see it here. So I typed go mod init and it generated that file. Let's see what happened. Okay, so it's saying it already exists because I did that earlier. But notice that the namespace that I've selected is just my first last name / time. So once I do that, once I put that in my module, I can refer to any packages in my code using that prefix, because I told the Go tooling that my module starts here. And then everything that's followed that prefix means it's basically going to be resolved to a subdirectory inside my root project. Hope that makes sense. If it doesn't, drop a question below, and then we could talk about it. All right. So now, instead of me doing the print statement we did earlier in the earlier version, I am going to use the function that's defined here in lib to display a short time. So let's see how that works. Let me go run. And you see now, instead of the long version of the time, date and time, we're basically using, we're calling this function right here to do that. Now, one thing I want to point out, and I did mention it earlier, but I'll point it out again. When a package, I'll point it out now, sorry. But when you create your own package, whether you want to make that package reusable locally, or make it reusable, from the internet, Go lets you hide what you can export from that package, for instance. And the way it does that is very simple. If you're coming from languages like a Java or C++, you're probably familiar with private members and public members, etc. Go takes a much simpler approach. So if your type, whether it's a function or a variable, if it starts with a capital letter, that means that symbol right here, or that function or that type, is exportable, meaning that it can be accessed from a different package once it is imported by that package. If it's non-capitalized, if it's lowercase, then that function is no longer visible from a different package. So let's do a quick test. So if I rerun this, because I was doing short time. Sorry. Let's do it here. So if I rerun this, so now it's saying, if we go back here, it's saying, hey, I don't know what you're talking about, because I cannot find that function. Basically, this package is not exporting a symbol or a type called short time. And even if I come here and press and do this, well, the tool just took it out for me. But now it's still going to say, I don't know what you're talking about. I don't even know what a lib is, because lib, the tool, the Visual VS Code basically took out that import because it was no longer relevant, because I was pointing to something that doesn't even exist. So I wanted to show you how you can export or hide members of your package by simply naming them with a capital letter or a lowercase letter. Okay, so let's undo all of this. And let's save this, and let's undo this. Okay, so let's look at the last, we'll look at the last example. And in this example, it's a little neat, but I'll wait till we get there to talk about it. So, okay, so in this example, I want to introduce the notion of importing a package, an external package that is not part of your project at all. So in this example, I'm importing 3 packages, fimped as before, and then the time lib as before. Okay, but I'm importing something called github.com/fogelman/gg. Now this package, it is not mine. It is something that's on GitHub, but I read about it earlier, and basically it allows you to create images dynamically. So what I want to do is take that time and generate a PNG out of it. Now, I don't have that. I I don't know how to do that, but the author of that particular package knows how to do that. So I'm going to do a package import and reuse their code to do that. So we pull down the package called GG. Now, before I do that, let's look at how we did that, right? Um, now three. Now, um, if we look at the, actually, let's look at it over here. Let's look at the Go mod file for this project. Now, because we're pulling down this package, the GG package, from up in the internet somewhere, now my Go mod will reflect my dependencies. Now, remember what I said earlier, the module for your project has two goals. First, it declares how you want to namespace your current module that you created, but also it declares any kind of dependencies you have on other modules. And that's what we're doing here. So how do you do that? Simple. Go comes with a tool called go get. So if I do go get, you'll see where I typed that earlier. So basically, Go understands how to pull code from several, actually from pretty much all popular code versioning repositories like GitHub, like GitLab, or Subversion, and possibly others. And this particular project happens to be on GitHub. So Go knows how to pull its packages from GitHub. So I don't have to tell it how to do it. The Go Get tools knows how to do that. Now, when I do that, nothing is going to happen now because I've already pulled it. What it does is it goes out, pull the package that I asked for, but also pulls any dependencies that package may have that it knows how to resolve. So that's why you see other packages are listed here. So Go Get automatically resolve any kind of dependency graph that I may have, which will cause the code for that I'm creating, which will make it compile properly. So that's what I did earlier, and with this command, and that's why you see that my Go mod in this version of the program looks like this. Whereas before we didn't have any kind of external requirement, now we do. Okay, so I wanted to show that. Now let's quickly go back to the program. And if you don't understand this, that's fine. The focus is not on this. The focus is just to show you how to use an external, to pull down an external package or module and then use it. So that's what we did. We're basically using the GG package here. And if you look at it, and that's what we're doing, we create a new context, and then we use the types that are inside that package to do some stuff, load a font, and then draw the string, and then output all of it as an image. So now, if I'm already there. So if I do go run now, it'll take a little time, and then it generates. So if you look, it just generated output.png, and it output the time. So if I do that again, actually, I'm not outputting the second, so it'll still say 233. But anyway, what I wanted to show you is how you can set up your own package, which we did, how you can use an external package, which we showed you how to do it, and how to set up your project and specify its module dependencies, which we did. So I hope that you learned something today, and then that's it. So hopefully this was informative, and I think I kept it under just about 30 minutes. That's the end, and we're gonna see if you have any questions and answer your questions.
Now, Vladimir, what I was able to do, I went through and grabbed some links. Emmett is listening from the car. We want to say shout out to Emmett. Um, but what I did do, I went and grabbed some links on like Go modules,
Hmm.
um, how to build Go packages as well. But here's a question I would have is, suppose I don't want to use VS Code. Um,
Hmm.
what would you recommend? What other IDE would you recommend for someone else
Uh,
that you would use?
so first of all, if you know the term IDE, most likely you probably have written code before. And if you have, I would say whatever IDE or super text editor that you're used to will work.
Okay.
There is I don't know where there is a list. If you search for Go IDE, there's a curated list of all of the IDEs that um, and the popular, of course, the popular ones, but the less popular ones that have supports for Go. And the level of support will vary. Some are full blown IDEs like your GoLand from JetBrains,
Mhm.
or even VS Code, and some are more text editor support where you'll still get some level of integration with a Go tooling, but it may not be as extensive as a full IDE. So, for instance, if you're using Vim, there's a very good Go support, Go support for it. That's been around for a while. Same thing if you're using Emacs. Same thing if you're using Atom. Same thing if you're using, whatever your favorite IDE is. Let me see if I can find it. But it's out there. Let's see. There you go. Well, those okay. So these are the ones that are the Visual Studio, Golang,
Mhm.
Vim. But there is one. It's this link. Yeah, there it is. IDEs, editors, and plugins that supports Go. So as you can see, the list is long. So NeoVim, VimGo, that's the one I was mentioning earlier. I've used that in the past, and then I went to I think Atoms, and then eventually to VS Code, and then I'm going between VS Code and um, and Golan, which is this guy right here. This is JetBrains Golan. Um, Emacs, same deal. You got several choices. Less popular, but still relevant. Like I said, Atom, BB Edit if you're on the Mac, um, JEdit. I've used that too. Um, what else that pops out? Notepad plus plus has plugins. Nova, Sublime. That's the other one I've used. Go Sublime back in the day. Anyway, and then you also have what they call in cloud-based IDEs like Cloud9, etc., which has support. So the list of, as you can see, the list of what's supported is pretty long. So again, pick your favorite IDE or text editor, and you're ready to go.
Cool. Now, one last question, and thank you for that. Well, one last question. So this morning on
Hmm.
our live, we were able to go to different jobs. One was with different companies and look at their jobs.
Hmm.
One company, the two companies that stood out to me was Square,
Uh-huh.
um,
Yep.
and yep, and the other one was a company called Proterra, and they
Okay.
do electric buses, but they were looking for an infrastructure engineer that could program and Go, and also a full stack engineer as well
Hmm.
too for Go, for the
Hmm.
application side
Hmm.
of the electric buses, and I
Hmm.
guess probably the interface as well too
Hmm.
for the buses. Now, with that being said, let's say, and I don't know if you're gonna be able to answer this in like 30 seconds or so,
Go for
probably not. Let's say someone goes to apply for that job, right?
it. Mhm.
And what would you, how would you recommend them doing a study to
Mm.
study up on their Go programming for that particular job?
Yeah. So again, if you're interested in that job, hopefully you've programmed before, but maybe you're not, uh, up on Go as high as you need to be, which is okay. Um, you know, because of that, I would say do a very surgical preparation. Focus on exactly what they're asking or what they may ask for. Now, the thing with Go is that it's all over the place as far as where it's being used. As you mentioned, infrastructure, Go is big in that space. Uh, development operation or DevOps, Go is big in that space. SRE, Go is big in that space. But Go is also big in spaces where you are doing cloud computing or create. So Go is big in places where you're building cloud computing tools, but it also big in creating and running applications that are also cloud native enabled, right? So Go is all over the place, wide spectrum of usage. And Go is also big in web development. Eventually, we want to get there. I want to eventually spend some time talking about it, hopefully sooner than later. So, having said all of that, if, for instance, you seeing that the position is for a full stack, where Go is part of the stack, I would say most likely focus on definitely the fundamentals, and that's why we're spending time to talk about fundamentals with Go. Um, spend some time on the fundamentals. Spend a lot of time on the fundamentals because once you understand the fundamentals, Go is a simple language. It doesn't have a lot of surprises, we spent time talking about that early, maybe a couple weeks ago. What when you're reading Go code, what you're looking at usually you can make out what the code is trying to do just by reading it. Go is a very uh, reader friendly language. So, but it still requires you to spend times with the fundamentals. Spend good amount of time with the fundamentals so you can understand what's going on. Again, if, as I said, if it's for full stack, then the next thing I would do is jump immediately into web development for Go with Go, because chances are that's probably what they want you to do. Web development with Go is very rich because you can go from I just want to create the backend code, or I want to create the backend code and also serve the uh, the the web resources, or it could be the front end is being done by somebody else, but my Go code is responsible for the service. So now we're talking about microservices or the service architecture in the back end. So that could be where you land. So I would say spend some time with Go web development. Tons and tons of documentation and how to do that is available. So you shouldn't have any problem figuring out what you need to do. And also, when it comes to web development with Go, there are tons and tons of frameworks out there that you can use. So which kind of not necessarily make it hard, but if you're going into if you're going into you being interviewed for that kind of job, spend the time on the fundamental, basically what you can do without those framework with Go, because those frameworks you can pull them. A lot of them you can just pull them out and replace them. But Go you can create fully functional, high throughput, high performance web application just with a standard library of Go. So again, spend time with the fundamentals, and hopefully it'll work out. Um, I don't remember what other positions. I remember the full stack and
It was the
infrastructure.
infrastructure. Yeah, it was the
Yeah,
infrastructure. It was at Squarespace.
yeah, same thing.
So we went over just some, what they were looking for an infrastructure person.
Right. Yeah, it's basically the same thing. If you're looking at infrastructure, obviously and hopefully. you're well versed in what that means, because somebody who's doing infrastructure automation, and infrastructure, architecture and infrastructure automation, is not necessarily doing the same thing as somebody doing a full stack, from front end to back end, creating application. So hopefully you understand what that means. Now, Go is again very well suited in that space, because the standard library in Go comes with all the bells and whistles that you're going to need to create infrastructure operations. And there's tons of blog posts and documentations out there how to do it with Go. Um, Whether you're doing it from scratch or using somebody else's library, tons and tons of resources available. How to use Go to automate things like, whether you're working with a cloud provider, or if you're not working with a cloud provider, how to write Go code to basically automate things that you would normally do manually. So if you don't want to go the Bash script or Python way, then Go is a very, very suitable choice for you to do automation.
Got you. Got you. And I'm looking through and checking see if we got any comments. I didn't see anything. I see people are watching and not in the chat. But make sure everybody who's on, make sure you like, subscribe, hit the notification button, share content, share it with your friends. Start diving in. Once we start opening up our whatever IDE or text editor and start creating our own little applications and so forth and deploying them to the cloud, that's really when it's really going to get intense, and we don't want anybody left behind. Uh,
Absolutely.
we thank you, Vladimir, for this week and your time. We'll be back next week again. Everybody, tune in at 11:30 for tech stocks and jobs. You tune in at 2 o'clock for 10 minutes ago. That's what we call it. We know it's longer than 10 minutes, but it's okay. And then the other one is today at 6 o'clock. We'll have our happy hour for our 5th year anniversary. Bring your drinks, and bring your drinks. We probably won't be doing any technical questions and stuff like that. The only thing that's going to be technical is how many shots can you get into your cup. That's the only thing technical about it. But until then, we'll see you all next week, and thank you for coming out.